So let's go meeting rooms 2 here. Okay, so meeting rooms 2, given an array of meetings time intervals where start and return the minimum number of conference room required. Okay, minimum number of conference room required. So if we just go by intuition, guys, you might already know that if, let's say, there is no overlap, then we don't need any extra room, and in that case only one room is sufficient, right? So so that's the first intuition, right? Yeah, and if there is a intersection of two intervals, then we can say that we need new meeting room, right? So how will we solve this problem? This problem, as we already saw in this article, it says that many questions are actually solved using priority queue. So yeah, we are going to use a priority queue here. And also this is actually a little tricky question, even though it looks simple. For example, this merge interval case, right? So it might so happen that there could be another interval which is um, also intersecting with this, let's say, second interval. Right now 0:30, 5:10, okay, 5:10 and 15:20, right? Yeah, this is actually a good example. So 0:30 is actually covering all these two meeting intervals also, right? So they are all intersecting actually. Yeah, but these two are not intersecting, right? So if we compare these two, definitely there is an intersection, so we need two meeting rooms, but this is like minimum how many meeting rooms we need, right? So what will we do as the first step? We'll sort all the intervals for sure. So that is what I'm going to do. So first I'll do some sanity check here. If intervals dot length less than equal to 1, then we can just return the intervals. Okay, so yeah, so yeah, minimum interval size we need to do this, like whatever sorting, any algorithm that on top of this we need two intervals, right? So yeah, first step, as I said, we'll do the sorting. Okay, sort these intervals array with a b by what, by the first index. Okay, so first index sort, first step. Okay, always first step is this one. It says, okay, sort by first index. See, okay, fine, we did it. Okay, now after sorting, let's say this example. Okay, after sorting, how does it look? It will become 5, 10, 0, 5 and 15. Actually, it's all sorted. Okay, so if it is already sorted, then what will we do? We will actually compare the end index of all of them. Okay, it is clearly, if you see this end index of all of them are not sorted, right? So if we sort them also, let's say we sort them also, let's see what is happening. Okay, 10 and then 50, 10, 20 and 10, 20 and 30. You see, so this guy, yeah, so there 10, 20 and 30, right? Yeah, so by the way, yeah, I mean, we'll go and see how this sorting by the second index will help us by using a priority queue here. But anyway, I mean, as like we already spoke about this, we'll sort and then what will we do? We are going to use a priority queue, and in the priority queue, if let's say there is no overlap at all, and then what will we do? We'll just go and push it to the priority queue, which has um, which is actually which is going to use the right index. Okay, uh, so we are going to push all the right index to the priority queue and take a decision. Okay, if there is no overlap at all, then what will we do? We'll just like keep pushing it to the priority queue, and we'll like if there is a um, if there is a overlap, then for when there is a overlap we need extra room, right? So then what will we do? We will actually, okay, how will I put it? Actually, what will we do? Actually, we need two operations. We need pull and offer, like push and remove, both operation in the priority queue, um, while iterating through this sorted list. That's what I'm going to do right now. Okay, and if there is no overlap, then we will just like poll. Yeah, we'll just poll it, we'll just throw it out. Okay, because if there is no overlap, then only one room is sufficient. So we'll start with the first. We'll keep um, adding and removing the list from the priority queue, and we'll be done. If there is an overlap, then we need two rooms. So in the case of overlap, we don't want to poll the element which is there in the priority queue. Okay, so that it will stay in the priority queue, and yeah, and always like we will compare with the lowest, like mean heap of the with the second index. Okay, so yes, end time we can say, right? So that's what I'm going to do right here. So we'll start with the, as I said, okay, okay, given an, okay, and finally okay, I forgot. So anyway, we are going to use a priority queue, as I said. Let's do this. Okay, priority queue. Okay, pq equal to new priority queue. Okay, fine. What are we going to push it here? So we are going to push the right like this, the end value of the interval. Okay, so you can say int, and the, yeah, it is a mean heap, so we don't want to add any comparator. Okay, we don't want to pass any comparator. By default it is mean heap, so it's fine. Okay, we'll push the uh, first value. Okay, so intervals pq dot offer. Okay, interval, the first value is 0 and 1. Okay, so end index. Okay, and time. Okay, now we are going to traverse through the array. So I'll say for int I equal to 0, I less than intervals length I plus plus. Okay, not from 0 because we have already pushed the first element here. Okay, we'll start from 1. Now we get the element. Let's say int let's say I call it, let's say curve equal to intervals I. Okay, so current interval is in curve. Now I'm going to do the I'll check if there is a overlap or not. But before that, we know that as I told you, we'll just we know that we'll yeah, so what will we do here? If like so we if we don't have any overlap, then we'll just pull pq dot offer. What are we offering here? We are going to offer the current element, right? So we can say actually current element and the first value. Okay, so if there is no overlap, then first is already there in the queue. We just pull and pull and offer. Actually finally you will be actually left with only one element, and we'll just return the size. Okay, so yeah, but if we don't have any overlap, we do this. Okay, but if there is a overlap, then we don't want to remove, we want to keep the merged, like we yeah, the meeting interval in the priority queue, so that it will be counted at the end. Okay, so we don't, how will we check if there is overlap? As I said, this here it is clearly written, like, valid interval, merge it, find, check if it is a valid interval. So that's what I'm going to do. Okay, even though it's easy, I'm just following the exact same pattern. I'm trying to follow the pattern actually, so that I don't have to think much in the interview environment. That's what I'm going to do. So int end, when I merge the both of the like current and the previous, let's say, okay, actually it is previous, right? Priority queue has the previous element, I can say. So and math and equal to math dot what, when there is a merge, we are actually looking at the maximum value of the first index value. So maximum value of the start time and the minimum value of the end time. Is it correct? So let's say, yeah, let's say, yeah, let's say 0, 30 and 5, 10. Then what will be the intersection? Intersection will be the 0 and 5. What is the maximum value of 0 and 5, which is 5? And what is the minimum value between the 30 and 10, right? So 5, 10. 5, 10 is the intersection. Actually 5, 10 is the intersection. Yes, that's what I'm going to do. So math dot mean what, current 1, right? Yeah, yeah, current value 1 and the peak element from the pq. Okay, so pq dot peak, and it is not, we are actually saving only the interval's highest value, so it will have the values. I'll say pq dot peak and current value. Okay, let's see. So now if I yeah, this is end, fine. And what will be the start value? Start value is math dot max. Okay, current so start value will be 0 and 5, which one is the max, right? So current is 0. Okay, and what was um, the max value of the, like, the previous value, right? So current is 5, by the way, and max value, actually we are not keeping it in the pq, but if you see this will be the max value. Okay, so current 0. Okay, start is current 0, it will be current 0. Yeah, now what is the formula for checking if it is valid or not? So very simple, start less than equal to end is the formula to check if it is actually a uh, valid window, okay, valid interval. So if it is valid interval, okay, that means it's a overlap, then overlap, okay. So if it is a overlap, then we don't want to pull, okay. Or if it is not a valid interval, then we want to pull. Yeah, so we have to say that start is greater than end, okay. Yeah, so current value start is 5 and and minimum of the value, right? So if start is invalid interval, you can say, right? So if it is an invalid interval, that means it is actually there is no overlap, and in that case we want to throw that interval out, okay. So yeah, is it greater than equal to we want to use or not? I just want to make sure of this. Greater than equal to or greater than, so yeah, I think greater than equal to is fine actually, because there are two meeting interval. Let's say let's say 1 and 2, and there is another one 2 and 3, right? Both are actually not overlapping, but the previous value for last index, previous value and index, and the current value first index, they are matching actually, right? And in that case we want to throw this actually out, okay. So that's what I'm going to do. Yeah, and that's it. So yeah, I think this is fine, and this is it, guys. Let's see, let's run this. I hope that I'm not doing any mistake. Let's see. Oh, there is nothing. Oops. Unknown network error. Why? Poll, not pull. Okay, yeah, passed. See, okay, cool, so it worked. Okay, fine. So this is important, guys, okay. We actually yeah, this is really important. I'm just following the template that I have created here. Yeah, I don't want to experiment different concepts here, okay. So how long did I take? Let's see.